just understand that. Follow me on this, class? Not only that, I don't even know how they're weighing it on Canvas when they get your overall average if you missed a quiz or something. So please just take that with a grain of salt. Don't see that as gospel. That's what you have, all right? And not only that, the last thing, so I don't keep on getting these questions. Your final grade is based on the actual formula I give on the syllabus. 40% of that is in the final. Does everybody follow me on this? That's a large portion of your grade. It really is. So to say this is what I'm going to get right now or anything like that is really premature. You can do very well, or you can do very poorly if you just blow it. But the final exams where serious students usually score the very highest, and I did a lot. I'm betting a lot of perfect papers, but I don't know that for sure, just based on past experience. Okay, now questions about the homework. I wanted to get that out of the way because I keep getting these little, they're basically the same question. Where do I stand in the class? And I try to explain it as best I can, but I don't know a better way other than tell you what I just said. Okay, any questions about the homework? The homework is diodes. They were ideal diodes. From my perspective, that is the simplest possible device. It's either on or it's off. There's nothing more to that. I prefer to do it. How many tried some problems? Be honest with you, tried these problems. Did you have any trouble at all? You did. Which one?
Can you work out 9-6?
I would be happy. Please ask guys, this stuff, and some of you probably had diodes and others for other things you did, but anybody tell me on men's basketball? Men's basketball. What? What? When? Tonight at what time? 8 o'clock. So that lot's going to be knocked off at 5. Play. I should know this. Does anybody know who we play against basketball tonight? All right. Who?
North Alabama.
Oh, all right.
And it was
9-6. Is that one? Okay, guys, give me your attention for this one. These are trivial if you understand what's going on, but they will confuse the daylights out if you don't. Remember, the device is on or off. It's called forward bias. It's a short circuit. Reverse bias. It's an open circuit. So 9.6. Here, they have this. So they want a graph of the function V out over Vn. Now, in engineering, this is very common. And I'll call this Vn right here. Vn versus V out, everything is with respect to ground. Remember, they're assuming that it's plus to minus here, plus to minus here. And the graph they're looking for is this. This is V out over Vn. Before you do anything with this, you start when there is no input connection. I'll redraw that in a second. This is real important. Then you'll see what goes on. Can everybody follow me on this? I removed the input. I completely got rid of that diode, anything that's a distraction from what's going on. Now, if I ask you this, remember this is an ideal diode. How many remember me talking about an ideal diode? If you don't, I want to go through it with you. If you have a diode like this, it says if current wants to flow that way in the direction of the arrow, it can. So if I had this type of a circuit here, and I had any voltage here, and it was plus or minus V, that's R. This would look like a short circuit because current would be trying to flow that way, or if a voltage could be developed, it would be plus to minus. Please be attentive here. I'm trying to be very clear with this. Does everybody follow me on this? So this looks like a short circuit. This diode is on. And this whole circuit can be represented as just plus to minus V. That diode is now a short circuit. This is R. And if I wanted the current here, it would simply be V divided by R. And if I wanted the voltage here, it would be V. Please watch. Does everybody follow? If the current can flow in the direction of the arrow, it will. The voltage there, if it was allowed to develop, would be plus to minus, but it's not allowed. It's a direct short. That's what it looks like. How many understand it? This is a very easy device, but if you don't be attentive here, you can get very confused very quick. All right, now, if current tries to flow in the opposite direction of the arrow, has everybody written this down? I want to use this die. The only thing I'm going to do is reverse the direction of that arrow. Everybody got this? I'm just waiting for a second. I want to make sure I got your attention. Can you read it? You good? You good? Or not? Still right. Okay. It's not hard. You guys okay with the back there then? No, behind you. You good? So now the only thing I'm going to do is reverse direction of the diode. Y'all follow me? Now, if current was allowed to flow, it would flow this way. Y'all follow me in that? It would be a plus to minus voltage developed if it was allowed to develop. If you just took that diode out, that's how it would be developed. Y'all follow me? This is a complete open circuit. It's nothing more than two dangling leads. It means I is 0 and the voltage here is 0. Y'all follow me? These are the only two possibilities for an ideal diode. Remember with the op-amp, there were basically two laws. No voltage across the input, no current into the input terminal. This one's even simpler. No current in one direction, as much current as possible, in the other it's a short. Now, getting back to this, based on what I said, right? There's 5 volts here. Listen. How much voltage has to be here for current to flow in this direction? 5 volts or better. Do y'all follow me? If it's 5 volts, current will flow. Do y'all follow me? And if it's 5 volts, now listen, no matter what this voltage is up here, or what the input voltage is, we'll see this in a second, the output, it's called clamped, will be clamped at 5 volts. No matter what, well, I can't say for sure, but we'll get there, all right? You all with me on this, class? How many see this? Now please, be attentive here. I'm trying to do this in a way that's logical, and people have asked me to be very, like A, B, C, if this is true, necessarily this is true, necessary. It's what used to be called deductive logic, all right? If the first premises are true, any conclusion must be true. All right, now, I know that until, now listen. Well, I'm gonna go, I'll do it. Was the arrow this way for this circuit or not? Tell me, or was it the other way? All right. Y'all with me? I'll take you through it. All right. Now, I'm going to go through the next permutation. Remember, this output right here, if there was no input, would be 5 volts. Y'all with me? Can y'all hear me? All right, let's take this. What if this is 0 volts or we short this to ground right here? Y'all follow me? That would be 0 volts. Do you agree with that? If there's 0 volts, current would like to flow this way, right? Do you agree with that? Remember, the only way current can flow this way if it's greater than 5 volts. Do y'all follow me? Now try to listen to me carefully about this. If that wasn't there, this voltage would be 5 volts. We agree to that, correct, class? Y'all follow me on that? If there was this was not there, this voltage V out would be 5 volts because the current would go from the 10 volt point, flow through the resistor, right? And it would be limited by 5 volts to that, right? So if this was 0 volts, well, current would flow this way, but since that's 5, current would like to flow this way. Just follow me, it's important you see it. Current would like to flow this way, but it can't because it's going against the diode the wrong way. Can you all follow me? Let me see your hands if you can. You have to think this one through. It's simple. Once you see it, there's no problem. So if there's 0 volts here, there's 0 volts out. With me? There's a second one. So I got 0 volts in, 0 volts out. Now, what happens is this gets negative. Well, no matter how low this goes, if it's -1, -2, -3, all this current would be 10 minus a minus, whatever that is, divided by R. All that current will flow this way, no matter how negative it gets. Do y'all follow me? So, as far as if the input voltage goes negative, it's just going to linearly follow that. I don't know how they show it in the solutions, but that's how it's going to be. Do y'all follow me, class? Do you see that in the solutions? You don't have the solutions?
No, I have them open. It's only the first quadrant.
All right, he only's doing positive. That's fine. He can go to 0 only, but it's going to start at 0, isn't it? Right? If you have the solutions there, you see it starts at 0 at the first quadrant from V in to 0 up. You have it, guys? I want to make sure. Can you see it right here? Does anybody else have the solution?
It starts at 0.
All right,
Only
it's
on the
starting
positive
0
end.
out, right? Now, follow me. As this starts going up, until the input hits 5 volts, it's going to linearly taper. This slope will be 1, and at 5 volts, something happens. Does she show that? Now, you see the reason. Because whatever this input voltage is, it will allow this diode to turn on, and this one can't turn on, because just take it, put it, this 0 volts, this is 5. Current wants to flow this way, it can't. Follow me? Think of it as a check valve if you're an ME. I think you've had that by now in your ME classes, right? But when all of a sudden this goes higher than 5 volts, current would like to flow this way, wouldn't it? Just think about this. Can it? Y'all with me? That's 5 volts right here, right? If this goes to 6 volts, current would like to flow that way. It was, but it can't because it's going the wrong direction, i.e. the check valve phenomena. So after 5 volts, the output is clamped to 5 volts. Now you asked me about this. Does this make sense to you? Think of it in terms of, I guess, analogs that you understand. You understand check valves. Hopefully this is a check valve. Current is like water in a pipe. That's all you think about, if it helps. It's a good problem. It makes you think and rationally deduce things. Plots oftentimes are the most difficult things with diodes because you're thinking about everything that can possibly happen. Always eliminate every variable you can. Get rid of the input. Take a look what the output is, regardless of the input, for the quiescent point, when there is no way an input can affect it. Y'all follow me, class? From that point starts working. So this is called a limiter. It limits the output voltage to 5 volts, but it tracks the input up to 5 volts. It can be called a clamper too, but the terminology doesn't matter. That's a great problem, by the way. because it really showcases it. Now, did you have another question? Good question. Did you do 9.5? You got it? Okay, good. You got 9.5. I'd like to do one more. Now, I mean, 9.4 is not bad. It's the kind of thing that will irritate people that are cramming. They might not get it right, but people that understand it will kill it. So I'm gonna do probably 9.4 for you. If you got another one, just yell at me. All right. All right, so what they want is the current through the diode and the voltage. Now, this is an extraordinarily easy problem, but I want you to just listen to me, please. First, there's only one source in this circuit, an 8-volt source. Can everybody see this? In the far back guys, over there? All right, 8-volt source. If there's only one source, current would like to flow out of the positive towards the negative terminal. No questions asked. Do you agree with that? With me? Can current flow in this direction? Yes. We've established that. So I'm just going to get rid of this diode and put a short in here to make my point a little easier. Now, if you're taking a look at this, after that change is made, do you see that these two are in series? 150 and 300. Raise your hands if you do, so I know who I. You guys understand this over here? This 150 and this 300 are in series. Do you agree? All right. So I'm going to replace them by 450. Everybody with me? So I'll get rid of that. Make this 450. All right. Now, without doing anything more, can we identify the voltage across that 400 ohm? Class? What is it? Everybody sees it's got to be 8 volts. Both of these are in parallel, and they're in parallel with that. If you actually move this thing up, you can slide it, right? Just slide it up there. Everybody should see that by what? Just by inspection, it's 8 volts. Are we good on that, class? How many see this? Now, what's the current? There's so many ways to do it, right? You could take 8 volts divided by 450, then 8 volts by 400 and add them together. Or you could replace these two with a single resistance. Do you agree with that? You all see they're in parallel? All right. What would that value be? I'm not sure. About 225, something like that? I'm not sure. Can somebody give me that?
211.7.
I'm gonna take your word. What's the current? Well, it would be that voltage, 8, if you're telling me the truth, over 211.7, or what, how many amps, I don't know, but it can't be that tough. 8 over 200, 4 over 100, about 4 milliamps?
0.0377.
Okay. You said 0.03, didn't you? 77 amps? Is that right? Or 37 milliamps, 37.7 milliamps. Do you agree with that, class? How many do? Now, I know I do it on the board, it may seem simple. On a quiz, a little different, pressured environment. If you do these problems, you'll get comfortable with this and it'll be automatic. It's like an op-amp, only easier. But if you don't do them, you can really have a catastrophe happen when there's multiple sources. Maybe one more before we move on. I'm trying to find one that would be interesting. All right, I tell you what, let's do 9-7, we'll do part A only. Because did I assign that one, by the way? 9-7 or not?
The solutions worked out, but it wasn't assigned.
All right, well, I'm gonna sign it now. Okay, so these are ideal diodes, that's the circuit. And what they're asking, what are they asking? What is the voltage across R2? And what is the current through the, oh, I'm sorry, my bad. And the circuit, what is the current through R1? When voltage is 10 volts, all right. So they're gonna let this voltage be a plus 10. All right. That's 4K, that's 2K, these are the diodes. Work with me on this one. Take a look at it for a second. Remember, they want the current, oh, what do they actually want? They want the current through R1. So they're looking for the current here. All right, now how do you do that one? I'm going to ask you, because the reasoning process is critical. Remember those diodes, they can be on or off. Go ahead.
I don't know if it matters, but in the book, R2 is 3.
Oh, is it 3K? Sorry.
Yes.
It matters. Matters for this one. This resistor is 3K, is that right? This resistor is 3K? The way I think that they would tell you to do this, if you were taking this from somebody who was a math professor, was go through all the possibilities. There are 4 basic possibilities. Both diodes are off. This diode is on, this is off. This diode is off, this diode is on, or both are off. Do you follow me? That's all possibilities. Then you logically determine which one would be allowed. Now that's a long way to do it, in my opinion. If you get used to this, you can see it right in the heartbeat. I mean, you can actually see it. Now, do you agree that we have only one source here, only one voltage, correct, class? There's no input, output, it's one voltage. Current would like to flow this way. Do you agree with me? First, do you agree with that? So that's where I always look. One source, you look at the direction current would like to flow. Now, if current flowed that way, and it's going to come back to the negative terminal, it could flow this way or this way. Do you agree with that? That's the only 2 possibilities from the top point I showed you. Do you agree? All right, now we go through it. Is it allowed to flow this way? Everybody see that? This is important. You see that? Is it allowed to flow this way? So I'm going to erase that in this whole business here because I'm going to make it real obvious. It can't flow there. Agreed, class? Don't get distracted with that. Now, if it is allowed to flow this way, I mean, if it would flow that way, based on the polarity of this voltage, then that diode is on. Do you agree with that? How many see this? You see it over here with me? Or not? I'm making sure. Do you see it or not? All right. And over here too, guys. You see it? So erase it and put a short circuit. I mean, that's why I tell people to start these problems. Just make it as simple as possible. Now, that circuit should be one we can all take care of and find the current. The 2 resistors are in series. Add them together, you get 5 k ohms, 10 volts. The current would be 2 milliamps. Do you agree with that? Now, believe it or not, that template of a problem will confuse the heck out of people that don't do them cram the night before. They will find all sorts of reasons to make mistakes. And generally speaking, it's like, it seems too complex. It's not complex. It's actually very simple. Would it matter? So I'm going to take this a step further. So here, I'm going to put a voltage, plus to minus. I'm just going to call it V, and I'm going to call it resistance here, R. Now I'm going to have this kind of a deal. All right, all the R values are the same, V is the same, or V is a value, doesn't matter. Now listen, if I want to know the current through here, just take a look at this, and make it say V is equal to 1 volt, R is equal to 1 ohm. I'm going to make this like ideal, perfectly simple. I want you to rationally go through that and tell me what in fact happens and why. Now just look at it, don't answer yet. I want you to take a good, careful look at this, and try to think through it yourself. I'm not gonna call on you, but how many think they have it? Don't say a word. If you don't have it, please listen. It's not hard. Remember, it's on or it's off. That's the way these things work. So, one source, current would like to flow this way. Agreed? If it flows that way, it would like to flow that way. Agreed? If it flowed that way, it would go through this resistance. Is that allowed? Yes or no? How many agree it's allowed? Replace the diode with a short circuit. That one. Here's what bugs me. I had one person come up to me years and years ago and said, "You never gave us a problem with diagonal or diamond shapes." The layout of the circuit topology has nothing to do with the circuit operation. You can have that thing in any shape you want. You all follow me, class? The only thing that matters is the electrical connections. All right, that's one thing done. It would like to flow this way, agreed? And like to flow, is it allowed to? Yes. Replace it with a short circuit. All right. These are the ones that get me. And I tell you, that's the reason I put this in. So people will take a look at this one. This is their reasoning, something like this. They'll say, well, it can't flow this way. It can't flow through there then, right? So that's an open circuit. But if you change them, this must be a short. That is a panic kind of reason. Y'all follow me? I mean, understand what I'm trying to get at. This is rational panic, or whatever you want to call it, because it makes no sense if you think deeply about it, but it does to the person at the time. If this one's on, if this one's off, this one must be on. In fact, what happens currently, it can't flow this way, right? Can it flow this way? No, both of them are open. Y'all follow me? So erase both of them. This part of the circuit is just dead. Got me on this one? I'm showing you what I think are the pitfalls with diodes. I'm just telling you what I've seen. You look at this, these two are in parallel. That's R over 2 if they're both the same value. Do you agree with that? It's in series with this. That would be 3/2 R. Do you agree? Or 3 ohms if it's 1 ohm. If the voltage is 1 volt, the current would be 1 over 3/2 or 2/3 of an amp. How many see this? Now that problem throws people if you don't think through it carefully. It's not hard, but people will make mistakes. And the reasoning they use, I call it rational panic or something, where they're trying to reason it out, but they come to a point where, I don't know, they're fearful. They just make bad choices. That's the only thing I can come up with. So I'm going to say that, and I hope that helped you. The rest of the problems, and you can do as many problems as you want like this, they're ideal. If you don't have the books in front of you, but there's a figure 8.8, it's for problem 8.8. They show all the various ways diodes can be kind of hooked in parallel or series. If diodes are in series and the current going through them is in the same direction, you can replace as many diodes as there with just a single diode. Do y'all follow me on this? If diodes in series are in opposite directions, it's an open circuit. Doesn't matter how many other kind of configurations there are in front or behind it. How many understand what I'm talking about right here? I gotta make sure everybody does. Now diodes in parallel, and I'll ask you this, because these are the type of things that trip people up. And I don't want you to be tripped up. Well, these are ideal diodes. We'll get to actual diodes in a second. Then the last thing we're going to cover, hopefully, is going to be bipolar junction transistors. But so, if you have diodes, and I'm going through the situation. Sorry. Okay. The parallel combination stuff I'll talk about in a second. Y'all with me, class? All right, if I was going to replace this with a single element, these are ideal dots, what would it be? Can you see that current can only flow this way in both? That could be replaced by a single diode, right? Can everybody see that that's equivalent? How many see that? With me? What about over here? Single diode only, current could go upward, right? So this looks like this. Agree? Doesn't matter if I have 3, 4, 5, doesn't matter how many. Y'all with me, class? As a matter of fact, you can make the case, this isn't exactly true in the real world, but if I had this, no matter how many are in parallel, this could be replaced by just this, if they're in parallel. Can you all see that, class? A short circuit in parallel with a short circuit is a short circuit. That's what they'd be if current's conducting up. If current's trying to go from the top to the bottom, they're both open, it's an open circuit. Now, you see it? I'm gonna make sure. How about this one? On purpose I put it there. Class? Doesn't matter what you put across there, no current ever flows. It's an open circuit. So erase it, kind of deal. What about this one? Think. Well, can current flow this way? If it's positive, yeah. If it's positive to negative, opposite, can it flow this way? It's a short circuit. Y'all follow me? That, in fact, those diodes don't do a thing other than confuse people. Y'all with me? So I want you to make sure you see these things when you do the problems. If you haven't done them, do them. They're not hard. The most difficult thing for you to do is force yourself to spend time on them because they seem too simple. I'm just leveling with you. These are very trivial problems, but if you don't spend time, you can get very confused, and I'm leveling with you. All right, now, I mean, they get a little more complex. I'll give you a few other ones, but in essence, what I've shown you is everything you need to know about ideal diodes. They're either on or they're off, and that's it. The next thing I want to talk about is I'm going to show you something that I won't quiz you on Friday, but it's a necessary stepping stone to get where I'm at with where I'm going with for bipolar junction transistors. And this is called the piecewise linear non-ideal model of the diode. It is used everywhere. This is something we use. The ideal model we use for large input voltages and stuff, large voltage changes. When you're getting down to of the order of 1 to 10 volts, we use this. It's called a piecewise linear model. Has anybody had this theory? I don't know if you would. I don't think you'd have that. So, in the chapter, there's a full wide wave rectifier, but we're not going to get there yet. It doesn't show this the way I'd like, but I'm just going to mention this. This is in, this is on page 288 and 289. This is the nonlinear, it's actually the piecewise linear model of diode, but he doesn't actually call it, this is not done the way I'm licensed. This is the model we use extensively all in electrical and computer engineering. Matter of fact, everybody uses this. And I'll show you. The ideal model is fine for 99% of the stuff you're going to be dealing with. But if you have very low voltages, you have to be a little more accurate. So, even though the actual equations that govern current to voltage across a diode are more involved, this one makes it work real well. So if you have a diode, and now, here's my diode. We have a voltage here across it. I'm gonna put a resistor here. Maybe I'll do it this way. And I'm looking for the current here. Now what they'll do is this is important. Current can only still flow in this direction, as before. But before the current flows, it has to overcome an internal voltage bias, which is about 0.7 of a volt. So what they'll do is say is this diode, this is called a piecewise linear model. Of a diode will look like this. In other words, the diode, you're used to seeing this for an ideal diode, will now become, this is the piecewise linear. You'll have an ideal diode here. This is ideal diode. But now you're going to do this. You're going to put this plus to minus, and it's called a diode voltage, and it is zero. Actually, in the book, it's going to say 0.6, but really 0.7 volts is typical for silicon diodes made from a silicon substrate. And they use an ingredient, it's an impurity called a dopant. Have you had any kind of transistor theory where they talk about introducing impurities called dopants in here? Anybody, you have in what class?
Ceramics.
Okay, anybody have ceramics in here before, besides this gentleman? You'll hear about this, and they can change the electrical properties. I'm not gonna do anything with solid state physics, but I just have to tell you that's where it comes. So, instead of using this model, we use this model. That is called the piecewise linear model of the diode. Now, what does that do differently than the ideal diode? Here's the thing that changed. And to be frank about it, we can keep on going. There's another thing they say is not only does this have this overcome this voltage, there's also a very small but measurable internal resistance. So they'll come and say there's some R diode here that's very small. Y'all follow me? So there's actually two things that have to be added, both very simple. A voltage that you have to overcome and a small value of resistance. Usually that small value of resistance doesn't have any real bearing on the overall current in the diode because other resistances are much, much larger. Do y'all follow me? All right, but just understand that. So, if you had this model, this is from ideal here. I mean, this is going to be the piecewise linear model that we use this. So now, what would be different from an ideal diode and using that to get the current? And let me see a problem and I'll show you. It's not hard to see. And again, I need you to be attentive here because I need you to understand this for me to go to the next step, which is bipolar. And I'm going to get it bipolar, but I'm going to use this as a stepping stone. All right, this is going to be problem 917. I'm going to just put it up here and talk about it first. All right, now for this problem, he doesn't assume the diode has any resistance at all. I mean, so that little, very small but measurable diode resistance is no longer a factor for this problem. But there is something, and he calls it VT0, just turn on voltage. It's usually given as VD. If you actually look at any kind of literature, it'll be voltage, and it'll just have a subscript diode. It's the voltage you have to overcome to have current flow through it. You all with me, class? He assumes the resistance internal to that diode is 0. So that's the waveform, and what they want you to do, I think, is sketch for a given input waveform, draw the output waveform of voltage. So he's saying this right here, I didn't draw it, but this plus to minus would be V out of T. You all with me? Now, I'm going to replace that diode with the piecewise linear model using the resistance of the diode is 0, because that's what he's basically saying, and an on voltage of 0.7 volts. So he has this. I guess I'm almost out of time. Here's the voltage. It's a simple sinusoidal voltage. 6 times sine of omega t volts right here. Now, you put in an ideal diode, and I'll just call it ideal diode, but then you put the voltage to overcome. Now, this voltage is something that will oppose. You have to overcome it to have current flow. This voltage is 0.7 volts. Then I put the resistor here, R, and if I'm looking for the output voltage, V out of T, y'all follow me on this one, right? I'm just showing you, literally what you do is add one element. It's like a small battery, correct, class? That's all it is. So if we have the input voltage here versus time, and I'm just going to show you one cycle like that of a sine wave. All right? I know it's time to go, just hang on. And I want, this is going to be the input voltage, sorry, or source voltage. And I want the output voltage as a function of time. Now look, this is the difference. Until, if you look at the input here, plus to minus, right, current would like to flow. It can't flow until this voltage is greater than 0.7 volts. Do you all see that, class? How many see that? And then it can flow. As a matter of fact, once you overcome 0.7 volts, all the remaining voltage is here. So what this will look like is there's going to be a dead spot until all of a sudden you got 0.7 of a volt, and it'll go up and then come down. It'll die before you hit here. And because of that diode, it'll keep on doing that same thing. So you're not going to have a full half wave output of the input voltage as you would with an ideal diode. You're going to be missing a little here and here. How much are you missing? Well, if you take 6 times the sine of omega t equal to 0.7 volts, you solve for omega t equal, basically you solve for the argument of the sine waveform, and if you know omega, you know time. Y'all with me, class? Give me a show of hands if you understand it. I'll give you some problems. On Wednesday, I'm going to start bipolar junction transistors, but please do these just so I have you on the same page as myself, because this next stuff can be very confusing if you don't understand this stuff. Okay, thank you.